presented by MrZOnTV.com. This is the Zcast. Welcome to the Zcast. I'm Mr. Z. In the last episode, we looked at the definition of the words force, motion, speed, velocity, and acceleration. Remember, a force is a push or pull with strength and direction. Motion is changing position. Speed is the rate at which that motion happens, and velocity is speed in a specific direction. We also said acceleration is a change in motion, speed, or direction. Today we're going to look at the laws that govern these terms. These are formally written down by Isaac Newton, and the first law basically says it takes a force to move a mass. In other words, if an object isn't moving, it won't move without a force acting on it. If it is moving, it won't change its velocity without a force. We call this principle inertia. Inertia means resisting change. In this catapult demonstration, the ping pong ball won't move unless the catapult pushes on it. It takes the force in the rubber band to move the mass, even though the mass is small. So law number one, it takes a force to move a mass. The second law states that force is related to the mass and how much it accelerates. We can look at that catapult again to see this in action. The ping pong ball has a little mass, so its acceleration is high. But what happens if we try a larger object, say a golf ball? You might think it accelerates more because it's heavier, but you'd be wrong. Because there's more mass on the golf ball and we use the same force, it actually accelerates less. So it's sort of like splitting a pizza with friends. The more friends you have, the less pizza you get. Well, maybe that's why I always get a lot of pizza. But hey, who needs friends when you got pizza? Okay, so the second law could also be stated as a math problem. F equals ma, where the F stands for force, m mass, and a acceleration. Okay, on to the third law. The third law basically says for every action, there's an equal but opposite reaction. If I put that catapult on wheels, when the catapult fires, you would see the catapult actually move backwards as it moves the ball forwards. That's because the ball has inertia. It resists, the catapult has to move back. So that's the reaction. Much like this meter stick here. If I move the top of it away from me, or the bottom away, the top comes back. So again, that law is in place here. It doesn't want to move, it resists. Tune in again next time when we take a look at these laws in a little bit more depth.